All right, here's our law of cosines video. Um, Heretofore, we have been solving for sides or angles of right triangles, and we've been using SOHCAHTOA to do that. Here we have a triangle that is not a right triangle. And what we are going to use to find the missing side lengths or missing angles, depending on what we're being asked for, are these formulas. So these formulas on the left are best if you're trying to find a side length. So you're trying to find side A, B, or C. And these are best for if you're trying to find the measure of an angle. And there's a few things that we need to keep straight when we're setting up our problems. In this example triangle that these formulas are based on, the angles are indicated with capital letters. The sides are indicated with lowercase letters, and the A's match up opposite each other. So this lowercase a is opposite from the capital A. This lowercase c is opposite from the capital, and so forth with the B's. Now, if you go rearranging the order and then using these formulas like this, you might get correct numbers, but they might be for different parts of the triangle, so your answer actually wouldn't end up being correct. So be careful that you are paying attention to those things when you set up the formulas, because they are specifically designed. This lowercase a, b, and c are specifically set up here to be across from capital A, capital B, capital C. And next week in class, we're going to derive some of these formulas for ourselves so that you know where they come from. But right now for this video, just take it on faith that these formulas work for their intended purposes. Okay, so in this first problem right here, we're being given A is 3, I should say lowercase a is 3, lowercase b is 7, so we know those are side lengths. Capital C is 130 degrees, so that's an angle. And we want to solve for everything else that's missing in the triangle. So we want to find side C and angles A and B, because those are the things that we are missing. So I'm going to start with finding side C. So I'm going to do this whole problem for you and then ask you to pause the video and try example 2 by yourself. So if I'm trying to solve for side C, I'm going to use one of these side formulas, and it'll be this last one that's already solved for the C squared. And I'm going to plug in all my given information. I'm going to plug 3 in for this A, 7 for this B, and then 130 for this capital C right here. Okay, and you will want access to a scientific calculator, a TI Inspire, Desmos, any kind of calculator that can do these trig functions. Your phone calculator would do. You'd have to be pretty careful with your order of operations, however. So if you were in class or using Desmos or a TI Inspire and you do this math ensues, you would have 85. And if you're trying to do it one step at a time because you don't have an advanced calculator, remember to follow your order of operations. Do your exponents first, then these multiplications. You would have to calculate cosine of 130, and then do add and subtract last. And you should get 85. And now what we want to do for here, because right here we're solved for c squared, but we actually want c itself, so I'm going to square root both sides. And normally this would give me plus or minus 85, but because we are finding a physical length, we are going to not include the negative. So it's just, oops, sorry, square root of 85 is not 85. It is 9.22 positive. So now we're going to find the missing angles. I'm going to start with angle A. Now for the angles, we want to use these formulas that are on the right. And if I'm looking for angle A, I'm going to use this one that is solved for cosine A. And when I go to set up my formula, A stays A because it's my unknown. And then if you notice on the right side of these formulas, it's all the side lengths. You would need to know all 3 side lengths to use these successfully. And because we just found C in this previous step, we have all of them. So everywhere I have an A, I'm going to plug in 3, 7 for B, 9.22 for C, and then on the bottom, -2 times B times C. Okay, order of operations happens, calculator work happens, math happens, and then we end up with 0.968. Now I haven't solved for A yet, I've just solved for cosine of A. So we are going to do inverse cosine to both sides. Inverse cosine cancels out cosine, leaving me A, and then on your calculator, go find the inverse cosine, or sometimes we call it the arc cosine, and that is going to give you 14.53 degrees for angle A. And then for angle B, we have 2 options. The first option is not my preferred option, but it's also not a wrong option. You can use this formula now to solve for cosine B, or you can remember that all 3 angles of a triangle add up to 180. And so therefore, I already know that one angle is 130 and another angle is 14.53. So 180 minus 130 is 50, and then 50 minus 14.53 is 35.47 degrees. And that is angle B. Okay, so I want you to pause the video and try example 2 by yourself. There are a few differences in the way example 2 is set up. The first difference is that it's all sides given to you, no angles. And then pay attention that B and C are backwards right here so that you get those in the correct order. So pause the video for a minute, try to finish out this entire problem. If you have all 3 sides, then you're solving for all 3 of the angles. Okay, here is my work. I used the formulas to find angle A and angle B, and then once I had those 2 angles, I just subtracted them off from 180 to get my third one. So pause the video so you can have that work and check yourself. All right, take a minute on, this is our last problem on the back. I want you to pause the video and read the problem to yourself and before you come back and listen to me talk about it. Okay, in this problem we have a surveyor. You may have seen these people standing on the side of the road. They'll have like a tall equipment that they're looking through and sort of angling left to right, and what they're doing is finding measurements. And so this surveyor is standing here looking at the front, this way to a front of a tunnel, so they're getting a measurement here with their equipment, and then they're rotating this way to get this measurement, and they're going to use those to find the length of this tunnel right here. So the problem tells us that this length here is 358, and this length is 523, and that this angle that's rotated between the two is 81. And we are being asked to find the length of this tunnel. We could use any variables we want here, but I'm going to choose variables that match these formulas from the front, my A, B, and C. So I have here already that this is A, this is B. I'm going to call this one C. The problem calls it P, but I'm just going to change that. So that'll be C, and then the sides across from my angles, if this is angle C, then the length of this tunnel, this side is going to be lowercase c. 358 is across from angle B, so that's going to be my lowercase b, and then 523 is going to be my lowercase a. And now that I have all those set up specifically like that, I can use the equations as they're written, and I don't have to worry about changing anything on them. So I'm asked to find the length of the tunnel, which is side C, so I'm going to use this formula right here. This is for finding side lengths. So C squared equals A squared. My A is 523. Plus B squared, which is my 358. Minus 2 times A times B times cosine of angle C, and I do know what angle C is. It's 81. All the math happens, whether it's your calculator, Desmos, your phone, your order of operations, and we get $343,113.3, and then we square root both sides and have approximately 585.76 meters for the length of the tunnel. And then this last question, what is the angle between the tunnel and the line from point A to point P? So here's my line from point A to point P, and here's the tunnel. So this is the angle that I'm being asked for, angle A. So pause your video for a moment and try that by yourself. Since you're being asked to find an angle, you're going to use one of these formulas on the right, specifically this one right here that says cosine A. Okay, and here is my work for that problem. Go ahead and check it. The only thing I can imagine you might be, if you're not getting the answers correctly, and you might need some calculator work, come in for tutoring and we can talk about that. Sometimes you're just getting off on how you're entering it into the calculator, or sometimes the calculator is in radians instead of degrees. So if you really feel like you're setting everything up correctly, but you're still getting the wrong answers, please come in and we'll talk about those things.